Magazine's Product Theater Thursday, part of the NWFA's Live Edge series. I'm Libby Johnston, publisher of Hardwood Floors, the official magazine of NWFA. Today's theater is sponsored by LATICRETE, a manufacturer of construction solutions for the building industry. Joining me now is Joe Rizzo, Director of Sales, and Nicole Gay, Senior Product Manager for LATICRETE. Thanks for being with us on Product Theater Thursday.
Thank you so much for having us.
Can you tell us a little bit about what we're going to see in your presentation today?
Sure thing. So our presentation is centered around moisture, its harmful effects, how it can be viewed, how it can be measured, what it actually does, and a pretty nifty way of cutting down its effects down to inconsequential or non-existent. I'll jump in first, and Nicole and I are going to go back and forth so that you guys don't have to just hear one voice and one face, although you would have been much luckier if it was just Nicole, but you are stuck with me for at least part of the time, so I hope we pass the audition. The nifty way that I refer to in our little introduction of what this presentation is about is a product by the name of Vapor Band Primer W, which is a moisture mitigation system, and I won't get into the details of it as part of this introduction because we'll do that shortly, but I would like to tell you a little bit about LATICRETE. So we are a family-owned, professionally managed worldwide company with a number of plants around the world. We manufacture products on all 7 continents, believe it or not, and our products are sold in most countries around the world. We are heavily invested in research and development, as we take great pride in being a company that centers technology around innovation. We started in 1956, so a number of years ago. We're getting close to our 70th anniversary, and we started in the tile and stone business. As a matter of fact, we invented what is commonly thought of as thin set for tile setting. As such, in that sector of the industry, we are quite well known and have made a lot of progress, but over the years, we do many, many more things than just tile and stone installation systems, including specialty materials for the mitigation of moisture, as well as self-leveling underlayments and patches and skims and everything that you need to install any type of floor, not just tile and stone. The company now is at about 2,000 people, so our reach is truly global and local, in that in addition to our own facilities, we have an extensive distribution network that sells our products throughout the US and throughout the world.
So let me introduce you to our newest innovation in moisture mitigation, Vapor Band Primer W. So this is a water-based, ready-to-use primer and vapor barrier all in one. So what does this mean for installers, or what this means for installers is fewer steps. So there's no separate primer, no mixing of an A and B component. You just open the pail, mix it, and apply. It's engineered for a CSP of 1 to 3 concrete prep, and it provides high performance protection at 100% relative humidity, 14 pH, and an MVR up to 25 pounds. That's industry leading coverage against the 3 biggest threats for flooring failures. With a strong bond strength that ensures that substrates are truly ready for final flooring installation, including self-leveling underlayments. Simply put, Vapor Band Primer W delivers speed, safety, and simplicity. It can go anywhere an epoxy primer can go, while also saving contractors time, labor, and material costs. Back to you, Joe.
Thank you. So we covered what Primer W is and what it does, but the question that should be obvious from this is, so what? Is it really solving a problem that we have? And the answer to that is a resounding yes. Moisture in substrates, moisture in subfloor systems is a real concern for many reasons, as we shall see. But the first thing that we have to look at is, where does it come from? There are 2 ways that there can be moisture in our substrate. The first is the concrete itself. Concrete is mixed with an amount of water that is used to react, commonly known as hydrate, the cement which is in it. The cement actually takes a different chemical form from the time that it is a soft gray or white powder to when it becomes this hard material that we know has great structural value. But that water is not enough to then give us the flowability for a concrete slab to be poured effectively. So the extra water, which is sometimes called water of convenience, is extra, and it likes to come out of the concrete. And that is essentially the water that you'll find in an elevated slab, except for other exterior sources. Now, we also have the water from external sources. If we have a slab of concrete that is on grade or on ground, we can have the moisture that is coming from the ground and the surrounding areas. This water, this moisture that comes through the concrete in the form of vapor, if there are no leaks, creates a hydrostatic pressure in addition to simply saturating and being present in the slab. With this type of external sourced water that comes from the ground, any moisture readings that we take of any kind are only snapshots in time. And what I mean by that is very simply that depending on the type of year or the last time it rained or the temperature or any number of environmental factors, what can be dry one day when we take a moisture reading on our slab, a month or 2 months later can be absolutely different, showing a slab that is completely saturated with moisture simply because there's more moisture in the environment and those environmental effects are different. So we have two different sources, a fixed source and a constant source, which can only diminish, which is the water of convenience in the concrete itself, and the water from external sources, which can be constantly changing. So let's see a few different ways of measuring moisture and the different types of readings that exist. Relative humidity in a slab measures the same way that relative humidity is measured in the air, in the atmosphere. And essentially, what 100% relative humidity reading tells us is that the air that are in the pores of the concrete is completely saturated with water. Picture that you're in Houston or Miami on an early morning and you see the dew on everything from the grass to the automobiles and everything else. That's 100% relative humidity in the air. That's the same manifestation in concrete itself. 100% is where that water becomes visible from vapor because it's super saturated the air. So now that we know what that particular type of wetness is, we express it as a percentage. So when I was talking about the 100%, that was a measure of saturation. And something like 50% means that the air is holding half of the moisture that it can possibly hold, which means that we probably can't see it. Things start becoming problematic for flooring systems, depending on the system, anywhere from 70% and above. And that is by no means an absolute number. That depends on your specific flooring system itself. The way that we measure moisture, relative humidity in concrete has traditionally been a method where we drill a hole into the concrete and place that relative humidity meter that you see in the picture on the left. More recently, the technology of electronic meters that are non-destructive test methods have become more dependable, more reliable, and are showing up on more specifications, in addition to the use of the relative humidity probes that we're commonly familiar with. pH is actually a fairly simple thing that not everybody understands. It is the measure of how strong an acid or a base a substance is. And when I say a base, I'm referring to a chemical base like we would see with ammonia or lye. which are considered highly basic materials. There's a method to the madness of the scale, which we don't need to get to too deeply, other than to say the scale goes up to a maximum of 14. 14 is a very basic material, so a strong concentration of the type of chemical that you would see in something like I said, something like lye and so forth. Concrete itself is a basic material with a reading of about 12. Water is considered neutral. It doesn't give up hydrogen ions. It doesn't take hydrogen ions. Simply said, it's neither an acid or a base in its distilled form. And 0 and 1 are very strong acidic environments. Most flooring adhesives can only take up to about a 9 or a 10 pH. And concrete, having a much higher pH, can damage the glue itself because of the basic nature of that material. It's important to keep in mind that the only time you can transfer the ions that I referred to before, the hydrogen ions, which is what makes a material acidic or basic, is with water. Dry concrete, regardless of its pH reading, will not do any damage for the simple and plain fact that water is the mechanism by which everything travels and does the potential damage. The way that we measure pH is with old-fashioned pH strips, which are sort of arbitrary because they what you're looking for in that little piece of paper that you see on the bottom of the left-hand picture, you get a color gradient. So it'll give you a general idea if you're dealing with a basic or an acidic material. The other more current method of doing that measurement is with the probe that we see in the right picture, which can give us a numeric reading of what our pH for alkalinity and acidity are, and that falls under ASTM F710, which is a more general specification containing many parameters for installing floors. EMVR, or moisture vapor emission rate, does exactly as its name implies. It measures the speed at which, the rate at which moisture comes into and out of our slab. So that can be dependent on how much moisture there is in the slab, but also the environmental conditions such as temperature and relative humidity in our environment. The reason I point that out, that it's not only dependent on the relative humidity, is because very often we are asked the question, what is there a direct correlation between MVER or EMVR and relative humidity? Is there a chart that somebody can go to and say, okay, 75% relative humidity is so much, so many pounds per 1,000 square feet per 24 hours of moisture vapor emission? And the answer to that is no, because we are also dependent upon the environmental conditions, which I measured before. As we mentioned previously, the moisture can be coming from the slab or through the slab. And this particular test, that white powder, or those white little round things that you see, are calcium chloride, which are trapped underneath a plastic dome, which protects from intrusion of moisture from any other source than the 1 square foot that we're measuring. The sample is weighed before the test, so we know what our net weight is of our calcium chloride. And then after 3 days, it is measured again. The weight is, that is, and we know the difference of the weight from our initial reading to our final reading is going to be the amount of moisture that we have collected per 1,000 square feet per 24 hours. We have the moisture itself, we have the movement of the moisture, we have the high alkalinity of the concrete, and all of that, the first thing that it's hitting is an adhesive, if there is an adhesive and it's not just a nailed down floor, and then of course the floor covering itself, which can be any type of flooring, We're concentrating, of course, on wood, as would be logical for the NWFA. We have two effects that are prevalent in everything that has been discussed so far. So the first effect is a chemical effect. The presence of moisture itself will chemically attack our glues. And those glues can be whether they're adhesives for wood or resilient or carpet tile, it doesn't matter. Different adhesives have different amounts of moisture, which they become sensitive to, and different pH, which they become sensitive to. So a glue will typically be rated for X% relative humidity and X amount of pH. By the way, there are no units for pH. pH is a unitless quantity for anybody that might have fallen asleep that day in chemistry class in their junior year of high school. Now, we also have one more effect when we're talking about having a slab on grade with the moisture coming from the bottom up with a vapor drive. We actually have a mechanical type of pressure of the water pushing up on our floor. So we've got the chemical effect degrading it, and then we have the physical effect of the moisture vapor pushing up into our adhesive and into our final flooring. All right, so what are the effects of moisture on wood? Pretty obvious. I mean, we know it because sometimes the moisture can affect the wood even before it's installed. But cupping, buckling, warping, and then we have the environmental effects in the wood and in the space itself, mold and mildew. Hopefully you guys haven't seen an application that looks like this, but I do suspect that many of you have. And of course, then there is the adhesive failure. So the effects are numerous and significant. In other types of flooring, we see this manifested in a similar mechanism, but a different manifestation. So if we have a floor that's not breathable at all, instead of cupping and warping in the same way that wood works, what we see is the bubbles of empty space with nothing but air and moisture in them, where our glue has given up the ghost, and now the floor is beginning to release. The slab on grade scenario is one where if we puncture into a floor, what will happen is actual water will come up through our flooring, and typically you'll see that more with the resilient type flooring than anything else, because the resilient is non-breathable, and that particular type of soft floor traps the moisture. Somebody punctures it, and then it comes up and seeps through. And if you've ever seen it, it's actually dramatic. It'll create a little, or not so little, spurt of water that comes up through a tiny little hole that makes it look like a water fountain for a few seconds. This is what the combination of the moisture and the pH will do to our glues. They basically turn them soft and into mush and incapable of acting as adhesives. It is the most disheartening feeling in the world when you walk over a floor that is still stuck there, but you know that there's something wrong because it's making these weird sounds, and it feels strange under your feet, and you know that it's a pervasive problem. One point that I need to make about high moisture tolerant glues and high pH tolerant glues. We're seeing a great advent in the industry in the last few years, where certain adhesives can actually tolerate 100% moisture, relative humidity, and 14 pH alkalinity. The caution to that is that they do not act, these adhesives do not act as barriers to that moisture. They are pass-through systems. So when your glue product data sheet tells you that it can take 100% relative humidity and 14 pH, all that means is that the glue itself will not break down. However, it does not mean that the moisture will not pass through that adhesive, get to your wood floor, or other types of flooring if you ever decide to cheat on wood. And it will damage. It will do the warping and the cupping that we spoke about earlier, even though the glue is still intact, because it will have the effect on the wood, if not the effect on the adhesive. And the final thing that we're going to talk about is efflorescence, not to be confused with the 90s goth metal band Evanescence, which is one of my wife's favorites. So I thought I would mention that. And efflorescence, rather non-melodically, shows up on the top of concrete slabs and will actually come up through certain floors as this white, salty calcium deposit that has a very ugly effect on slabs. And if your slab happens to be on the type of floor that allows the passing through of that efflorescence, such as in a tile application where it will come through grout, and it will become visible, typically efflorescence will not come through a wood floor, although there is a chance that it might come through the joints, but it's unlikely with the configuration and the density of modern wood floors being tongue and groove and nice and snug. But that salt buildup, and essentially that's what that mineral is. It's a type of salt that comes up with the moisture, and the only way that it can be carried through the slab and underneath your floor is with the presence of moisture. Otherwise, it will not have any way or any reason to exist and come up through the slab. So even though it may not come through a wood floor, it will be sitting there resting underneath. So you've got this nice efflorescent layer underneath your wood floor with your possibly mushy glue and your mold propagating moisture. So back to Nicole.
Thank you, Joe. So the moisture mitigation market is growing steadily at 6 to 8% per year. North America holds the largest share, driven by high construction volumes and specification-driven projects. The biggest growth is in healthcare, education, government, and data centers, sectors where strict flooring specifications and reliable performance are absolutely essential. So why is moisture mitigation so important? Because flooring failures due to moisture are amongst the most common and costly callbacks in the industry. Contractors and owners now recognize that vapor barriers are not just an add-on, they're an insurance against failure. And that's exactly what VaporBand Primer W is, a low-cost insurance policy. We're also seeing more fast-track construction schedules, which means that slabs don't have enough time to cure naturally, and adding to that stricter warranty demands, it's clear why a product like VaporBand Primer W is gaining attention. So from a contractor standpoint, it also provides the opportunity to grow your product offering. So some key benefits include protection up to 100% relative humidity, ready to use. It's a water-based formula, so you don't have to mix the A and B component. It's safer to handle, less mess, and reduces job site hazards. There's strong bond strength that supports self-leveling underlayments. There's a full system compatibility with warranties up to 25 years. And it's safer, it's faster, and it's simpler for installers while protecting the long-term performance of the floors. So VaporBand Primer W is ideal for moisture and pH sensitive floor coverings, both slab on grade and elevated slabs. It's packaged in 5-gallon pails with 36 pails per pallet. Applications do require 2 coats. So there's a base coat and then a secondary coat That can be done within 1 to 2 hours of the curing time for each, depending on site conditions. And then you'll use a wet film gauge to confirm an 8 to 10 mils per coat. Coating average is 88 to 100 square feet per gallon across both coats, and LATICRETE stands behind this product with a comprehensive warranty package. So the warranty ranges from 1 year for a product warranty to system-based warranties with 1, 5, 10, and even 25 when used within the LATICRETE system. So this provides both peace of mind for contractors, specifiers, and building owners alike. Finally, Vapor Band Primer W is part of a broader LATICRETE moisture mitigation portfolio alongside our epoxy-based solutions like Vapor Band E and Primer ER. We now offer a whole full range of options, whether your priority is speed, safety, or maximum performance. LATICRETE has a moisture control solution that will fit your project needs. So we also understand that launching a product is only part of the story. Making contractors feel confident using it is just as important. And this is why we have a full range of support materials and educational resources. You'll find brochures, safety data sheets, and warranty information to support specification and job site use. We're also developing a dedicated LATICRETE University module for online learning so your teams can get up to speed anytime, anywhere. There's instructional videos that are available on YouTube, as well as Inside Track, which is a Facebook-based group covering both product overviews and step-by-step application guidance. And finally, we continue to engage through industry webinars like this one today. All these resources are designed to make sure you and your teams can use Vapor Band Primer W with confidence and with success. That's the end. Thank you. Now we'll open it up for questions. And we've also provided Joe and my contact information should you need to reach out to either of us following this presentation.
Great. Thanks for all of that information. As you said, we'll start taking some questions. So our first question is there an upper limit on the relative humidity percent in concrete?
So the upper limit is 100%. Anything above 100% relative humidity means that we have reached saturation. So we transfer from moisture vapor to liquid water. And at that point, we're dealing with water, not just moisture vapor. The limitations of the Primer W are 100% relative humidity and 14 pH. So like the existing epoxy systems, the two-component epoxy systems, which are a bit more traditional, this water-based single component product has the same performance and the same upper limits.
Okay. And then is Vapor Band Primer W easy to apply?
Man, I love questions like that. Yes, yes, it's very easy to apply. So our traditional moisture mitigation systems are two-component epoxies, right? So picture this, you've got a job to do. The first thing you need to do is to get a surface profile, if you're using an epoxy, that resembles a 60 grit sandpaper. That's how rough you have to get the concrete, a CSP3. You then have two components, an A and a B, to mix together, sometimes inside an enclosed structure, which is being used in other areas, other than just the area where we're doing the work. And you have to very precisely mix the two components and put them on this highly profiled floor. Contrast that with Primer W. One component, open the bucket, it's pre-mixed. The surface preparation, which is required for the Primer W, is much less. You can go down to a CSP of 1, which is what is commonly referred to either as a brush blast or can even be achieved with a sander, not necessarily a grinder. And the biggest reason to do that amount of substrate prep is to make sure that our slab is clean. So we don't have to get the kind of profiling that we need with epoxies. So yeah, it's easy.
All right, next question. Can you use any adhesive with your sealer?
So all of the adhesives that we have looked at have not had any compatibility issues. We work with by the way, we don't make at least right now we don't make adhesives for wood. So we work with manufacturers of these types of adhesives, and we get tested for. I don't like using the word compatibility because it makes technical people in technical departments and legal departments all sorts of nervous with its legal implications. However, having said all that, yeah, everything that we've seen so far, you can use our adhesive, excuse me, our primer W under adhesive. I do want to make a point which was not stated specifically in the question, but maybe the root of the question, so I'm guessing a little bit here. When you use an epoxy moisture mitigation, there are certain glues that you have to put a cement coat, whether that's self-leveling underlayment or whether it's some type of a patch or a skim coat on top of the moisture mitigation. And the reason for that is that water activated glues do need an absorption layer underneath them to grab some of that water and to activate the glue itself. So yes, this as a moisture mitigation system will, we hope, fingers crossed, not absorb any water at all. So you will need a cement-based 1/16 inch layer, give or take, if you're not using, if you weren't intending on using self-leveling for flattening the floor. So hopefully that fully answers all the concerns of that question.
Okay, next question. As an inspector, how do you tell if they use it at the right spread rate, square feet per gallon?
So if you're inspecting while the process is happening, our recommendation, and it's in the descriptive literature, is that a squeegee is used, similar to any type of coatings or epoxy squeegee, basically something that looks like a notched trowel, but instead of being a metal trowel, it's a thicker piece of rubber with the triangular notches in it. And those squeegees are rated for a certain amount of mill thickness. So if you're there, the first thing you look at is you can compare the number of units that are on the job with the square footage of the job, and we give a spread rate. So assuming that on the most basic level, we've got the right number of units for the right square footage, the squeegee will then tell us that it's evenly spread throughout. And after squeegeeing it, the product then gets backrolled. One more thing, if you're not there when the product is being placed, the only way to do it is destructive testing, where you core into it and cut out a piece of the product itself and measure it with calipers. And there is, by the way, a number. So if you apply, let's say, 2 coats of 8 mils thick when it's wet, it'll be slightly less than that. So you can call either Nicole or me, and we can tell you, oh, 16 mils thick, that wet should be X mils dry. And that was my long way of saying I don't remember what that number is right
now. Okay, and next question is, are there instances where your 2-part epoxy should be used instead of primer W?
Yes. The one place that we would definitely recommend using an epoxy is if we have found that we have a very, very high hydrostatic pressure. So we're on a slab on grade, or actually even worse, a slab well below grade, where the water table is above us. So we have this mechanical pressure that's coming up. epoxies will have somewhat of a higher bond than a single component system. So yeah, there still is a place for epoxies. There are other applications too, and we would be very happy to, you know, look at things on a one-to-one basis. Also, there are certain specifications because of the number of years that epoxy moisture mitigation systems have been around. There are certain architects, certain engineers that write their specifications strictly for the use of epoxy. So yeah, we're always advocates of following the specification.
All right. And then can I apply a self-leveling underlayment on top of Vapor Band Primer W?
Not only can a self-leveling underlayment be applied on top of Vapor Band W, it actually acts as a very effective primer. So anyone who places self-leveling on a regular basis knows that not just LATICRETE, but pretty much all the manufacturers will tell you that if not 100% of the time, 99% of the time, you need a primer for self-leveling. Vapor Band Primer W, and that's why we have the name primer in the name, acts as an excellent primer that fills all the functions of enhancing adhesion and blocking pinholing like any other primer. So you don't need an additional primer. You save that primer step.
Okay. And then how long does the product take to dry?
So that's a question with a variable answer. It's kind of like asking how long does it take water to dry, right? If it's a very wet environment and you know, a cold day, it's going to take longer. But most of the time, a couple of hours.
Okay. Once it's dry, can I install LATICRETE underlayment directly on top of Primer W without applying another primer?
Yes. Plain and simple. No qualifications. Yes.
Okay. And then is your product warranted when applied to a slab with known hydrostatic pressure?
The product is warranted with hydrostatic pressure. However, the one thing that we all need to be careful of, contractors, inspectors, and manufacturers alike, is that we don't have active leaks in our concrete. So if all the leaks are sealed off, then essentially all we're getting is a vapor drive, not liquid water pulsing out through cracks and holes in the concrete, the warranty will apply. And now that I've said it, we have to do it. So.
All right. Well, is there anything else you would like to add?
Our appreciation
Yes.
to the NWFA and to everybody that attended today. Many thanks. And you know where to get us because we gave you our numbers.
Absolutely. Feel free to reach out to Joe and Nicole with additional questions. To learn more about the products featured today, visit laticrete.com. This presentation will be made available on nwfa.org. Thanks again to LATICRETE for joining us for Hardwood Floors Magazine's Product Theater Thursday, and thank you for attending. Have a good afternoon.
Thanks, Libby.
Thank you.